In this example, we're asked to prove that if n is a positive integer, then n is odd if and only if 5n plus 6 is odd. So let's start once again by listing the assumptions given to us in this problem. And we are told, so this is kind of worded in a somewhat confusing way, because this first if n is a positive integer, that's just an assumption. So we are told here that n is a member of the set z plus, which is how we denote our positive integers. This then is just, it's not really part of the statement that we're trying to prove. It's just a English word connective there. And what we want to prove is this statement right here. N is odd only if 5n plus 6 is odd. So let's try to unpack this one a little bit. N is odd. We can call this our P. 5n plus 6 is odd. We can call that Q. And remember, the only if statement, this is not if, this is only if. The only if statement represents an arrow that goes this way, right? If it said n is odd if 5n plus 6 is odd, then we would assume the right-hand side and work our way back. This one starts with an only, it says only if, so that means we should start with the n is odd as our assumption and work our way toward the right. So now that we've unpacked that, what assumptions do we need to write our proof? Well, the assumption that we get to make is that n is odd. We do not get to assume that 5n plus 6 is odd. That's what we're going to prove, okay? That's what we're going to prove. So what does it mean for n to be an odd number? Well, this means that there exists an integer k. In this case, it's going to be a positive integer because of our setup up here. The n is a positive integer itself. So there exists an integer k such that, n is equal to 2k plus 1. Even numbers are of the form 2 times k for some integer k, and odd numbers are either 2k plus 1 or 2k minus 1. And since we want this to be a positive integer, I just chose 2k plus 1 as my choice here to make this an odd number. All right, so these are the assumptions, and we know exactly what we want to prove now. We want to prove that if n is odd, then 5n plus 6 is odd. So we're ready to write the proof. Remember, the assumptions are not part of our answer per se, if this was a question that you're submitting for homework or something. So we draw a line and we write proof. So we've indicated that we are starting the proof now. Okay, here's how we start. Let n be a positive odd integer. Alright, so I'm going to wrap up both of those statements into one statement here. So let n be a positive odd integer. Then there exists, I'm just unpacking our definitions that we wrote down up here, right? So then there exists a positive, or at least a non-negative. So I guess if k is 0, then this could still be an odd integer, right? So we'll write it like this. So there exists a non-negative integer k such that n is equal to 2k plus 1. All right, this is just a consequence of our assumption that n is a positive odd integer. All right. Now, what do we want to do with this? We want to multiply 5 times n, add 6, and show that that's an odd integer as well. Okay? So all we have to do now is kind of do the math, so to speak, right? So then, what do we have? 5 times n plus 6 is equal to, and at this point we can kind of list this out. We can list this out as a math equation. So this is equal to 5 times 2k plus 1 plus 6. All right, and I'm going to distribute this out and write this as 10k plus 5 plus 6. And at this point, I want to make sure that this can be written in the same form, right? Our conclusion that we want to prove is that 5n plus 6 is an odd number, is odd integer. So at this point, I need a 2 to come from here. So I'm going to write this as 2 times 5k. And this number adds up to 11, right? So I'm going to rewrite this, though, as plus 10 plus 1. That's 11. And as you can see, 10, we just did this with 10, right? 10 is even, so this can be written as 2 times 5k plus 2 times 5 plus 1. And why am I doing all this? Well, I want to be able to factor out a 2 from this portion, right? So I'm trying to get this form of our number in this proof. So this then factors to become 2. 2, so this is then 2 times the number 5k plus 5 plus 1. All right. And by the way, because k is an integer, 5 is an integer, integers are closed under addition and multiplication, we can then say that this is true where this number 5k plus 5, let's call it m, is an integer. All right. So thus we've shown, write this down, we've shown that 5n plus 6 is of the form 2 times m plus 1 for some integer m, and this all happens under the assumption when n is an odd integer, and therefore under these assumptions 5n plus 6 is odd. All right, so we can say that finally, therefore, 5n plus 6 is odd. And that's it. That's what we wanted to prove. Put our smiley face. We're happy. So notice how this worked. If we go back and just talk about the structure of this one, we make our assumption, we apply the definition of our assumption, we then plug the definition into what we want to say something about this term, right? So this is part of our conclusion. We plug it in, and then we use legitimate mathematical statements, right, to rewrite this, to manipulate this in some sense, to rewrite this in a way that it also matches the definition of our conclusion, which in this case was the same, right, that this integer should be odd. All right, so that's the structure of this kind of a proof. This is a direct proof. Very straightforward in some ways, but make sure you understand everything that's going into it as far as the proof writing goes.